Hello students, hi, good evening. So we are discussing the electrostatics force and field concept. Already first session we have talked about how the understanding of charges has developed. Okay, then we have come to the modern concept of the charging of objects. Modern concept in like when an object is losing electrons, net other charge will become what? Positive. Gaining electrons and other charge will become what? Negative. Okay, so that's the modern concept or modern understanding of the charging of the objects. So charging of the object is because of what? Because of the imbalance in the number of electrons and number of protons. Okay, so protons and the nucleus only electrons will be exchanged. Okay, so any substance, typically metals, lose electrons. So the total charge will become what? Net it will become positive. And if there is a substance like non-metal, gaining electrons and the charge on that will become what? It will become negative. Okay, so we'll start with the discussion. Already in the session 1 we have started looking at the properties of the charges. Okay, so we'll continue in today's session, and also we'll look at the important law related to the forces between the charged particles and the Coulomb's law. So we'll also get introduction into the Coulomb's law in today's session. Okay, so Paranga, we'll start with the properties of the charges. So we'll look at the first property. So like even in the genesis of the understanding of the charges, people are able to know there are basically two types of charges, because some charged objects were attracting each other and some were repelling each other. Okay, so in the modern concept of charged objects also we'll have two types of charges. Okay, so the charge that will be deficit in terms of electrons, okay, that will be what? Net positive. Here because we are considering the electrons to be having a negative charge, that is the convention. Okay, so basically the protons and electrons, they'll have a same magnitude charge, and the they'll have same magnitude charge but opposite nature. எப்படி differentiate பண்றதுன்னு சொல்லிட்டு we have assigned one of them to be positive, which is the protons, and ரெண்டாவது we have taken the convention as what? Negative. Okay, but that does not mean that proton charge is a higher value and electron charge is lesser. It is not referring to the comparison. அப்படி compare பண்ண முடியாது. Positive means higher, negative means lesser. அப்படி compare பண்ண முடியாது. This is only to tell that these two are of different nature of charges. Okay, and if there is an object is having excess electrons, so the net charge will be what? Negative. So there are two types of charges. Okay, and how do we understand the difference between the two types of charges? If we have like charges, right, they will repel, and the opposite charge will attract. So like this is positive, it's getting repelled. Okay, and this is negative is getting what? Attracted. So naduvil positive, right? The positive is repelling the other positive, and it is attracting the negative charge. Okay, so this is one of the very popular statement that we will use. And the like charges will repel each other, unlike charges will be attracting each other. Okay, at the property part, the total charge on an isolated body will be always conserved. Conserved and if something is remaining constant, conserved and sollu. Okay, paranga total charge of an isolated body. Isolated body and so if you have any object isolated means what? It is not going to come in contact with anything else. Okay, now if it is not coming into contact with anything else, it will neither be able to lose electrons nor will be able to gain electrons. So contact then it will neither be able to lose electrons nor will be able to gain electrons, which means what? On the object whatever the charge, the total charge on the isolated object will be always remaining what? Constant or conserved. Okay, so this is another important property of the charges. And the third and important one for numericals. So based on this we'll have numericals, and the charge is always quantized. So quantized and another, like in the chemistry also we'll use this word quantized very much. Quantized means what? Like in +1 chemistry chapter, right? You will talk about the Bohr's quantization. So what do we talk about? You talk about Bohr's quantization. Okay, so Bohr's quantization principle. What is Bohr's quantization principle? So electrons, when they are revolving, they will revolve in only those orbits where the angular momentum of the electrons will be what? Some integer multiple. So n is what? In this case, n will be a positive integer. So integer multiple of h by 2 pi. This is what we call as Bohr's quantization principle. Means first orbit la the angular momentum will be what? H by 2 pi. Second orbit la it will be what? 2 into h by 2 pi. Third orbit la 3 into h by 2 pi. And the madri fourth orbit la it will be what? 4 into h by 2 pi. It will always be coming in terms of the steps. So when we go to second orbit, first orbit la when you go to second orbit, it is increasing by how much value? H by 2 pi. And the madri second orbit la third orbit la when you are moving, it will be what? Again increase of h by 2 pi. So the angular momentum is what? Quantized. Means it can only take the multiples of this h by 2 pi. It can only take the integer multiple. Normal multiple can only take the integer multiple of this h by 2 pi. Okay va? And the madri we have also seen quantization principle somewhere else. And the Planck's quantum theory. What is it? Planck's quantum theory. So if you have energy that is carried by the electromagnetic waves, it comes in the packets. One packet will be having how much energy? H into nu. Nu is the frequency of the electromagnetic radiation. Okay va? So if you are having total energy given by the radiation, what is the representation? We'll say n into h nu. Is the same. N is what? Positive integer. Either we'll get 1 packet of energy, Elena will get 2 packets, otherwise we'll get 3 packets. We'll always get what? Integer multiple of this h nu. So that is what we call as the Planck's quantum theory. Quantum and another, anything happening in discrete levels. Continuous discrete levels it is happening. That is what we call as the quantum. Okay va? So inga paranga, we are talking about the quantization of charge. How the charge will be quantized? Because remember, what are we saying? When an object is getting charged, it is getting charged by either losing electrons or gaining electrons. That is how the object is getting actually charged. Okay. Losing electrons, it can lose 1 electron, lose 2 electrons, 3 electrons, maybe 1 lakh electrons. Always it will be what? In terms of integer multiple of electrons. Gaining electrons also same thing. It can gain 1 electron, otherwise it can gain 2 electrons, it can gain 3 electrons. If it is losing electrons, means on the object charge will become what? Totally it will become what? Positive. Gaining electrons and anything, it will become negative. So we can write the charge as plus or minus n into e. N is what? N is a positive integer. Okay, so n is what? Positive integer. Otherwise, some textbooks they will write like this: q is equal to n into e. They will say n is what? Integer. It can be a positive integer or it can be a negative integer also. Okay va? So a ipdi varadhan paatha, look at it. No, so if it is losing 1 electron, means the charge will be what? Plus e. Losing 2 electrons means charge will be what? Plus 2 into e. Losing 3 electrons means charge will be what? Losing 1 lakh electrons means what? Plus 1 lakh into e. E is what? Basic charge. Other value 1.6 into 10 power minus 19 coulombs. Okay va? If it is gaining electrons, gaining 1 electron means charge will be what? Minus e varum. Gaining 2 electrons means minus 2e. Gaining 5000 electrons means what? Minus 5000 into e. Okay, so always the total charge on the object will be equal to what? Plus or minus n into e, where n is what? Positive integer. N is what? Positive integer. E is what? Basic charge. Okay va? So because it is happening in the steps, steps of that basic charge. Okay, so paranga, either it is E or it is 2E or it is 3E, like it will be always happening in terms of what the steps of the basic charge. Okay, either positive it can be negative. So loss of electrons will be totally charge positive, gain of electrons and total charge will be what, negative. But overall nama paatha, what is it going to be? Charge is always going to be quantized. We cannot have charge on any object like 3 by 2 into E, we will not be able to charge, or no 5 by 3 into E, we will never be able to have charges like that. Okay, we will always have charge as what, plus or minus n into E, where n is a positive integer. Okay va, so is the quantization of the charge. What do we call it as? We will call it as the quantization of the charges. Okay, so no madri idilanda we will get some numerical questions. Topic this is more like theoretical understanding of the charges. We will start getting the numericals. So look at this. What is the value of charge on 1 mole of electrons? So mole pati already you would have studied in chemistry. What is the mole? So 1 mole of electrons means 6.022 into 10 power 23. What is a mole? 6.022 into 10 power 23. That is what is mole. 1 mole of electrons and we are having 6.022 into 10 power 23 electrons. Of course, the total charge on these electrons will be what? Negative, because each electron is having negative charge. So if you are just looking at the charge value and the verum charge value mattum paatha, what is it going to be? 6.022 into 10 power 23, that is the number of electrons. Each electron mele what will be the charge? Basic charge 1.6 into 10 power minus 19 coulombs. Okay, so we are just looking at the charge or the magnitude or the value. Okay, so why I am talking about this, Terima? This is a very common unit of charge that you will use in plus 2 chemistry. So you will be using this in electrochemistry chapter. Okay, so you know what is it called as? 1 Faraday and so on. What is called as 1 Faraday? What is 1 Faraday? Charge on 1 mole of electrons. Okay, actually the coulomb, right, is a large unit of charge. Paranga, look at the charge on the electron. What is it? 1.6 in 10 power minus 19 coulombs. Okay, so it's a very small amount of charge. Coulomb is a larger amount of charge that we'll use in common problems solve pannumbodhu we'll talk about the coulombs. But when it comes to the chemistry, right, you will always have importance associated with the idea of 1 mole, like 1 mole of atoms, 1 mole of molecules, 1 mole of, so you'll always talk in terms of this mole, which is an important number in chemistry. And you will see that in electrochemistry you will have importance of this Faraday also. Okay va? So we are just supposed to find what is the value of charge on 1 mole of electrons. Check it, students. If you get the answer means you can just type it over there. So we just have to simplify this multiplication. How is that? What is the value going to be? Check it, students. It's an important value of charge. So if you do this multiplication, right, we are going to get, so actually this value of basic charge we are taking is rounded off to 1 decimal place. What is the value we are choosing? 1.6 in 10 power minus 19 coulombs. But if we take it up to the number of decimal places, like the way we have in the Avogadro number, அப்படி பண்ணா then we are going to get a slightly different answer. ஓகேவா? so நீங்க இப்படியே மல்டிப்ளை பண்ணா you will get one answer. like if you multiply 6.022 10 power 23 with 1.6 into 10 power minus 19, அப்படியே multiply பண்ணா you will get one answer because we are considering the charge of the electron to be only up to one digit. ஓகேவா? but if you consider the charge value also to be up to 3 decimal places, you are going to get a little bit a different value for this. so எவ்வளவு வரும் தெரியுமா? how much we are going to get? We are going to be getting the value somewhere close to 96,500 coulombs. okay, so actual value எவ்வளவு? 96,485 coulombs, but what we will take it as approximately, we can take it as what? 96,500 coulombs while solving problems. okay, so we will use this conversion. 1 Faraday will be equal to what? 96,500 coulombs. That is what generally we use as a conversion factor between the Faraday and the coulomb. okay va? so what is this Faraday? Faraday is a larger unit of charge. Paranga, it's a larger unit of charge than the coulombs. what is 1 Faraday? correct sollanna, what is it? 96,485 coulombs. okay, approximately what we can say? 96,500 coulomb. okay, so this is the value of charge on 1 mole of electrons. It's a simple thing, right? we are just 1 mole means what? Avogadro number of particles dana. so we are looking at 1 mole of electrons means Avogadro number of electrons. Avogadro number is what? 6.022 into 10 power 23. அப்படியே அந்த வேல்யூ நம்ம மல்டிப்ளை பண்ணோம் பேசிக் சார்ஜோட. ஓகேவா? so அதுல இருந்து we are going to get what is the charge of 1 mole of electrons in terms of value. so நீங்க கேட்கலாம், ஏன் சார் நம்ம மைனஸ் இங்க எடுக்கலன்னு சொல்லிட்டு. okay, because we are looking at what? வெறும் அந்த சார்ஜோட வேல்யூ மட்டும். okay, otherwise you can even keep minus because this is going to be what? Negative. The total charge on electrons is going to be what? Negative. okay, okay guys, so we'll move on to the next question. what is the number of electrons lost? what is the number of electrons lost by a metal object which has a 4.8 coulomb charge? so the metal object mele they are giving the charge. எவ்வளவு? they are saying the charge on the metal object எவ்வளவு? 4.8 coulombs. நம்ம என்ன find out பண்ணனும்? we need to find out what is the number of electrons lost by the metal. so இங்க பாருங்க 4.8 coulombs ன்னு சொன்னா what is it? positive charge தானா? இதனா this is the positive charge. positive charge எப்போ வரும்? when that object is losing electrons. when we are going to get the positive charge? when the object is losing electrons dana. so as per the charge quantization, namak enna irukka formula? charge on any object will be equal to what? plus or minus n into e. idhula nama minus edukka poradhu kediyadu. yen already the object is given to be having a positive charge. so q is equal to n into e. idhula irundhu nama enna calculate pannom? so what is this n representing? n is representing what? n is representing the number of electrons lost by the metal object dana. so what is this n representing? n is representing the number of electrons lost by the metal object. okay, so if he is losing 1 electron means charge will be what? E. 2 electrons lost panna it will be what? 2e. 3 electrons lost panna it will be what? 3e. அப்படி தானா? so we need to find what is the in the n order value. okay, so what we are going to do? q is equal to n into e is an equation. இதல அப்படியே அந்த வேல்யூ சப்ஸ்டிட்யூட் பண்ணனும். q எவ்வளவு? 4.8 coulombs. okay, is equal to n into e is what? basic charge. basic charge value 1.6 in 10 power minus 19 coulombs dana. coulomb cancel ஆயிடும். பாருங்க 1.6 once 1.6 3s dana. 1.6 into 3 என்னது? 4.8. okay, so இப்ப என்ன இருக்கா? 3 அந்த சைடுல இருக்க 10 power minus 19 it will come to the denominator is equal to n. so denominator 10 power minus 19 இருந்தா when we take it to the numerator it will become what? 10 power plus 19 ஆகும். so what is the answer? 3 into 10 power 19. பாருங்க just அந்த 4.8 coulomb charge காக how many electrons the metal object is losing? it is losing 3 into 10 power 9 means 3 க்கு அப்புறம் we are going to get 19 zeros. அத்தனை number of electrons it must be losing. okay, so since the charge of one single electron is very small value, right? if you want to obtain the normal charge in the range of coulombs, on the level of charges நம்ம attain பண்ணதுக்கு we are going to be requiring exchange of large number of electrons. okay, அடுத்த question போலாமா? so what is this question based on? this is based on the quantization of the charge. It is based panni, this question is based upon the quantization of the charge. Okay, look at this one. What is the total negative charge? What is the total negative charge on 9 grams of water? See, water, it's a neutral molecule. Water is a neutral molecule. Neutral molecule dana, which means on the water molecule whatever the total positive charge value will be equal to total negative charge. But in what they are asking what is the total negative charge. Verum on the negative charge mattum they know on the neutral molecules kulla whatever the total positive charge will be equal to total negative charge adheriyum. But they are asking what is the total negative charge. Eppadi pandrathu paranga. So all these are very common questions. Common questions based on the application of this quantization of the charge principle. This is based on the application of the quantization of the charge principle. Okay, so eppadi inda problem solve pandrathu. First we look at ஒரு water molecule எடுத்து பார்க்கலாம். Let's just look at one water molecule. Water molecule குள்ள என்னென்ன இருக்கும்? You will have 2 hydrogen atoms and 1 oxygen atom. அதுதானா? So each hydrogen will have 1 electron. So இதுல நம்ம electrons மட்டும் பார்க்கணும். ஏன்னா they are asking only about the negative charge part. So each hydrogen is having 1 electron. அந்த மாதிரி oxygen, right? What is the atomic number of oxygen? Oxygen atomic number என்ன? 8 தானா? So it will be having 8 electrons. Totally பார்த்தா each water molecule will be having 10 electrons. With the number of electrons, each water molecule is going to have 10 electrons. Okay, so here we are having how much amount of water? 9 grams of water. What is the amount of water? 9 grams of water. Okay, va? So 9 grams of water na, see what is the molar mass of water? 18 grams. What is the molar mass of water? 18 grams. Eppadi varum 18 grams? There are 2 hydrogen atoms. Gram atomic mass of hydrogen is 1. And what is the gram atomic mass of oxygen? 16 grams, right? Total enna varum 18 grams. That is the molar mass of water. Okay, so what is the given mass? 9 grams. So idhilende we can find what is the number of moles of water. Number of moles eppadi calculate pandrathu? Given mass by molar mass dana, which is what? Half. What is the number of moles of water molecules? Half is the number of moles. Okay, so number of moles of water molecules half means what is the actual number of water molecules? What is the actual number of water molecules? Will be what? Half into Avogadro number dana. So what is the actual number of water molecules? Half into Avogadro number means half into 6.022 in 10 power 23. What? That is the total number of water molecules in 9 grams of water. Okay, so namakku enna theriyum already ஒரு molecule we are having 10 electrons. எத்தனை molecules இருக்கா? We are having how many molecules? Half into Avogadro number. Okay, each molecule, what is the number of electrons that are there? 10 electrons. Means each molecule kulla what will be the amount of negative charge? The amount of negative charge will be equal to what? 10 times of the basic charge. Idhula nama negative edukkiradhu kediyadu. Enna we are just looking at the value. What will be the amount of the negative charge? It will be 10 times the charge of 1 electron. Adana ena 10 electrons irukka, which means what? The total negative charge will be equal to 10 times the charge of 1 electron, which is the basic charge. Okay, so what is the total number of molecules in our hand? Half into Avogadro number. So paranga total negative charge. Idhula namakku straight a value varum. Total negative charge. Total negative charge will be equal to what? Total number of molecules half into Avogadro number into what is the negative charge on one molecule? 10 into basic charge dana. Paranga, what is it? 10 into basic charge. Okay, so finally enna varudhu? Already we have this result. Munadi problem solve pannirukom. What is it? 6.022 into 10 power 23, which is the Avogadro number into basic charge. Adoda value enna? What is that? That is what we are calling as 1 Faraday, right? That is what we have called as 1 Faraday. What is it? We said we can approximately take it as what? 96,500. What we can take it as? We can take the value as what? 96,500. 500 approximately. Okay, so அப்படியே அந்த 6.022 in 10^3 Avogadro number value multiplied by basic charge. So half into another 96,500 coulombs into 10 irka. So what is it? Paranga 2 ones are 2 fours, adukaprom 2 eights, 250 into 10. What is it? 4,82,500 coulombs. What is it? 4,82,500 coulombs varum. So here we are taking the value of that 1 Faraday charge and 1 mole of electrons approximately as what? 96,500 coulombs. Okay va? So like this, we will be able to solve the problems little bit quickly when we remember some of the standard result. In the standard results remember panna, then we will be able to easily do these kind of problems. Okay va? So this is what we are calling as the quantization of the charge. Now when we look at the types of charges while we are dealing with, in the chapter full ave the charge objects base panni da nama deal panna porom. So when we look at the charged objects, right, we will categorize them into the two types. One another point charge and sollu. Like in mechanics problems we will talk about point mass and sollu. What do you call it as point mass? You know what point mass means? It's a theoretical concept. Point mass and it's a theoretical concept. What is it? We'll take the mass to be located at a single point. But actually appadi irukuma? No, right? The mass cannot be at a single point, and a mass will occupy some volume. Matter occupies some volume, right? But theoretically we will use the concept of point mass in mechanics. And the madri inge enna theriyuma, we will use the concept of the point charge. Generally, what is the symbol that we use for the charge? Either small q or capital Q. Okay, so when we say point charge, it represents what? We are keeping the charge at a location. Like assumption another, we are assuming that it is not occupying any volume. It is located at a single point. This is also what? Theoretical. Eppadi nama the point mass is a theoretical substance, so and the madri idhila enna point charge will be a theoretical. Normally enna irukum? Any object which is charged means it will be distributed in some volume. Adukku nama enna solluvom? Distributed charges. Any object, like you think about spherical shell agatum, or you have a solid sphere. So normally any object you take will be what? Distributed charge only, because when they are having a charge means they are having the charge in some volume. Okay, so then adukku nama enna solluvom? We will call it as what? The distributed charges. Okay va? So when we are dealing with the point charges, we will have a certain approach, and the distributed charges deal பண்ணும்போது we will have a different approach. Okay, எப்படி அந்த difference நம்ம பார்க்க போறோம்னு சொல்லிட்டு we will be able to get the further understanding when we go to the actual problems. But this is how we look at the two types of charges. One is the point charge, ரெண்டாவது distributed charge. Okay, now we'll just summarize this with some differences between the charge and mass. Idhilandi we can possibly expect some theoretical questions. Okay, adukku mela we will not have any numericals or anything based on that. Okay, so first of all, charge can be positive, it can be negative, it can be zero. We have seen uncharged object means what? It is not having any charge. Positive charge can be there, negative charge can be there. But mass appadi kadiyadu. Mass is always what? A positive quantity. Okay, we'll have a concept of negative mass. Maybe if you are interested, neenga poi edavadhu a lot of documentaries available on the idea of the negative mass. Okay, so but that is a different concept. But normally nama mass and sonna, what is it? We are only considering the positive mass. Okay, and charge carried by the body does not depend upon the velocity of the body. Like you have a charged object which called Q. When that object is moving with a velocity, the charge on the object will not change, but another mass will change. So we will learn about it in the chapter of modern physics. Adala we will talk about how the mass of the object will actually depend upon the velocity. Okay, so you use the concept of rest mass. In paranga, if m0 is the mass of a body at rest, adukku nama enna solluvom? Rest mass nu solluvom. Okay va? And if the same body is moving with a velocity v, then you know what will be the mass of the body which is in motion, adukkenna what is the formula for the m? M will be equal to what? M naught by root of 1 minus v square by c square. So what is the mass of the body in motion? So in the formula we are going to discuss about it when we go to the modern physics chapter. Okay, so adula we are going to discuss about it. Eppadi in the rest mass and mass in motion will be different. Okay, what is happening to that? So if you look at it, right, so there is a difference in mass. Why the difference in mass coming adalla we are going to discuss about it in the modern physics. But ingana therima we are trying to understand the basic difference. Charge appadi kadiyadu. Charge cannot change. Whether the object is at rest or it is in motion, charge will be same. But mass, we have the concept of rest mass and mass of the object in motion. The difference will be significant only when the v value is comparable to c. C means what? Speed of light. Formula la, if v is very small, c oda value anna 3 × 10⁸ meter per second. On top of it we are having c square, means it will be what? 9 × 10⁻16. So the v value should be comparable to the c. Appoda and the difference namakku theriyum. Illana what we are going to observe? We are not going to observe much difference. The rest mass and mass in motion, we are not going to observe much difference when the velocity of the object is small. When the velocity of the object is comparable to the speed of light, appoda we can see the difference between the rest mass and the mass of the body in motion. We are going to discuss about in the modern physics context. Okay, so the difference paranga, charge is quantized. Okay, mass also as per the theories, okay, is quantized. There are some theories which propose that mass is also quantized, but no, there are some counter arguments also. So the quantization of mass, right, is we'll say is yet to be established. Established panla. Charge quantization is already established. Okay, so when you look at charge on any object, what do we see? We will see that charge on the object will be always equal to what? Plus or minus n into e. N is what? The positive integer, and e is the basic charge value. Okay, so electric charge is always conserved. Electric charge is always conserved means what? If an object is losing charge, other object will be gaining charge. If one object is losing charge, means other will be what? Gaining charge. So the total charge will be what? Conserved. The total charge will be what? Conserved. Okay. Mass appadi kadiyadu. So in lower standards, right, probably in the chemistry you will study that, okay, mass is conserved and solid. But in +2 physics, we are going to learn that mass can be converted into the form of energy and vice versa. Okay, so you might have seen this very famous equation, right? E is equal to mc squared. So what is it? This is the Einstein's mass and energy equivalence relation. Okay, so this is what is called as Einstein's mass energy equivalence relation. In the equation based panida, we will be able to find out how much energy will be resulting when a mass m is changed into the energy form. In the equation based panida, we will find out how much energy exchange will happen during the nuclear reactions. Okay, so mass is not conserved because it can be changed into the form of energy. Okay, the difference paranga, force between charges can be attractive or repulsive. Like charges they will repel, unlike charges attract. What is the force between masses? Gravitational force. Remember the definition of gravitational force. What do we say? Two objects having mass will always attract each other. We'll say two objects having mass will always attract each other. Means what? The gravitational force between two masses is always attractive in nature. Gravitational force between two masses is always attractive in nature. Okay, so we will not have gravitational force to be repulsive. Okay, so we'll look at one more question before we go to the next concept. So we have to mark the correct options. We have to mark what is the correct option. Okay, so now we just have to read. So the question like these kind of questions, right? These are tricky questions. And It is not like one question. They are just saying, mark the correct. They are giving us 4 statements. So we have to read each and every statement and then check whether that is correct or not. It is like, almost 4 problems given into one question. Okay. So option A paranga, total charge of the universe is constant. Option A is the total charge of the universe is constant. Okay. We'll come to that little bit later. Look at option B. Option B is the total positive charge on the universe is constant. What is option B telling us? Total positive charge of the universe is constant. We'll just take one very simple example. Okay. So our object A and our object B. Let us assume that initially both of them are what? Uncharged. Initially both of them are what? Uncharged. Okay. So in the object A landu, we will just give 1 coulomb charge to object B. Then what will be the charges on A and B, because we have taken the charge out. Negative dana. So it will be what? Minus 1 coulomb, plus 1 coulomb. So initially they both are what? Uncharged. Initially they both are uncharged. Finally both are charged. Object A is negatively charged, object B is what? Positively charged. When we say that total positive charge of the universe, in the 1 coulomb count பண்றது கிடையாது. When we talk about the total charge of the universe, right, எல்லா object மேல charge we are calculating, but in the object B is neutral. So in the 1 coulomb நம்ம calculate பண்றது கிடையாது when we are counting the total positive charge. But இப்போ என்ன ஆயிட்டிருக்கா, we have to add this 1 coulomb, right? இதுவும் positive charge தானா? So the total positive charge on the universe, right, need not be constant. When the objects are exchanging charges, right, it can so happen that the total positive charge value can change. And the C paranga, total negative charge of the universe is constant. This is also incorrect. So option B is incorrect. C is what? Total negative charge is constant. So same example. Initially both A and B are what? Uncharged. But finally object A is having negative charge. So if we negative charge count we are going to count that minus 1 coulomb present on the A also. We are going to count the minus 1 coulomb present on the object A also. This is having a negative charge. We are not counting charge on A. Why? Because that is uncharged. So paranga, second case or final state when we talk about total negative charge, so we are going to count that minus 1 coulomb on the object A also. Okay ba? So this is also incorrect. Total negative charge in the universe need not be constant. When the objects are exchanging charges, right, what we see, total positive charge on the universe can change. Another total negative charge on the universe can also change. Option D paranga, the total number of charged particles in the universe is constant. This is incorrect. Initially object A, object B are what? Uncharged. So on the two objects நம்ம அந்த கவுண்ட்ல எடுக்கிறது கிடையாது. So we are not counting them as charged particles, right? But இப்போ பாருங்க, when you are counting total number of charged particles, final state la we have to count A also as well as B. A is charged, B is also charged. Okay. So is the total number of charged particles remaining constant? No. The total number of charged particles is also not remaining constant. It need not remain constant. Why? If two neutral objects are exchanging charge, then what we are going to get? Once they exchange the charge, we are going to get two charged objects. We are going to get two charged objects. So what is the correct statement? The total charge on the universe will be constant. See, A is uncharged, B is uncharged. Now A is giving 1 coulomb charge to B and then finally what is the charge on A? Minus 1 coulomb. What is the charge on B? Plus 1 coulomb. Okay. Initially, let us say capital Q is the total charge of the universe. Let us say Q. Value. Okay. Q is what? Total charge on the universe. Okay. So if our final state we want to find the total charge of the universe, means what? Q is the total charge of the universe initially. We have to add this plus 1 coulomb on B and minus 1 coulomb on A. This is the charge on B, this is the charge on A. This is add panna. 1 minus 1 evla 0. So totally what we are getting? Q only. Totally what are we getting? We are getting the value Q again. Okay, va? So the total charge of the universe will be always going to remain constant. Okay guys, so these are the kind of questions that we will be able to good Maithili. Okay, so Arthadena, we are going to look at so the correct answer for this is what? Option A. So we are going to go to the next important concept. What is it? Coulomb's law. Okay, so remember, in the understanding about the charges, all this has evolved because they were able to find a new force which is stronger than, they're able to find a new force which is stronger than the gravitational force. Other than that, the interest has come to people. So how people have got the interest? Eppadi and interest varudhu? They saw that between objects, when they are charged, they are able to exert or create a new type of force which is stronger than the gravitational force. Other than the people started looking at, so why they are getting charged, but the basic idea is what? The observation of this stronger force between the charged objects. Okay, so Coulomb's law is going to explain how we can measure the force between these charged objects. Okay, so Coulomb's law is going to explain how we can measure the force between these charged objects. Okay, but when we look at the Coulomb's law, right, actually when Coulomb was doing his experiments, he did the experiments by using small spherical charges. He has done the experiments, he has done the experiment by using small spherical charges, very small. Okay, va? And he used to take the distance between the centers of the small sphere, sort of center to center distance. That is what he used to take as the distance between the charges. That is what he used to take as what? Distance between the charges. So this is how he has done the experiments in terms of measuring the force between the two charges. Okay, on the experiment basis, he has proposed the Coulomb's law. Okay, so what is the law that is proposed? We call it as what? Coulomb's law, and this is also called as inverse square law. So what is the other name that we give for the Coulomb's law? Another inverse square law. So Coulomb's law and Solar law, we can also say it as what? Inverse square law. We'll look at what is the Coulomb's law. So though Coulomb did the experiment for the small spherical charges, where he took the distance to be what? And the distance between the charges, and so now what is the distance he took? He took the distance between the center to center in the sphere or the center and the sphere or the center, and the center to center distance is what he took as the distance between the charges. Okay, va? But when we are making the statement of the Coulomb's law, general statement, we will make the statement for the point charges, because when we say distance between two charges, right? So we say distance between the two charges means, in the charged object, this is a charged object. If I have to say distance between the two charged objects, so can I say this is the distance, or should I say, I'll use a different color marker, should I say this is the distance between charges? Distance we will not be able to take a value as the distance between the charges when the charges are what? Distributed charges. When the charges are distributed charges, we cannot use the word distance between the charges. Okay, va? So the law, Coulomb's law as such, is proposed for what? Point charges. So what is it? If you have 2 point charges, say Q1 and Q2, if you have 2 point charges Q1 and Q2, they may be positive, they may be negative also, which are separated by a distance R. So R is what? Distance between the two charges. They are separated by distance R. Okay. Then the force of attraction or repulsion. The force may be attracting force. When it will be attractive? When both charges are unlike charges. Positive, negative attracts. It will be repulsive when Q1 and Q2 both are positive or both are negative. Then they are going to repel each other. The force of attraction or repulsion, force we are taking the magnitude of the force. Paranga, the force of attraction or repulsion is directly proportional to the product of magnitudes of the charges. Where on the charge at a magnitude. Okay, so the force is proportional to what? Product of the magnitudes of the charges and inversely proportional to the square of the distance between them. அதுக்கு தான் நம்ம என்ன சொல்லுவோம், inverse square law சொல்லுவோம். Force of attraction or repulsion, right, is inversely proportional to square of the distance between the two charges. அதனால what are we saying? We are also calling it as what? Inverse square law. Okay va? So whenever we have this proportional relation, we can convert this into an equation, right? So Coulomb also converted this into equation form. So when he has written this into the equation form, he has to use a constant, right? Proportional relation nama equation maathumbodhu what you should have a constant. The constant he has introduced is represented by the symbol small k. Capital K kadal small k. Okay va? Small k is a symbol and the small k will now be called as what? Coulomb's constant. Idhukku enna solluvom? We'll call it as what? Coulomb's constant. Okay va? So this is what is the Coulomb's law. So Coulomb's law gives us what? It gives us the expression for the magnitude of the force between two charged particles. The force of attraction or repulsion, right? Although the magnitude is given by what? K into mod q1 into mod q2 by r square. This is based on the experiments that he has conducted. Okay. Some people also write it like this. The force magnitude is equal to overall of mod. Also put it like this, full modulus. Apadi nama eludala. Okay, either you can put k into mod q1 into mod q2 by r square, illana they can also take full modulus. Edukku nama modulus edukkiradhu? Because here we are talking about the force or magnitude. Remember, any vector, right? Vector magnitude will be always what? Non-negative. Any vector can have a zero magnitude, but vector magnitude cannot be negative. Why? Because we can represent, remember, a vector by a line segment, right? Means we can have a line segment of zero length, but we cannot have a line segment of negative length. Okay va? So this is what is the Coulomb's law expression. So neenga note panikonga. What is it? This is the Coulomb's law expression. Now in this, right, we have talked about this Coulomb's constant K. Okay, remember, whenever we get a new quantity or new constant, generally enna theriyuma, the constants, some constants will be unitless, some constants will have units. Some will be unitless and some will be having what units? Idila the constant K will be having units. So let us try to find what will be the SI unit of this constant. And the madri, what is the dimensional formula? Neenga check pannunga, what is the SI unit? So what is the formula we have? Coulomb's law formula anadi, the force magnitude is equal to what? K into mod q1 into mod q2 by r square. So left hand side la force dana, which is Newton, is equal to K into adana brackets lo vechikalam. Q is what? Charge, which is Coulomb. Idanadi Coulomb dana, divided by r is what? Distance, which is meter. So inga paranga idella nama left side eduthu ponom. So meter square will go to the numerator. Coulomb into Coulomb anadi Coulomb square dana. So paranga Newton meter square divided by Coulomb square. That is the, what is it? This is the SI unit of Coulomb's constant. Then this is the SI unit of Coulomb's constant. And the madri, we can also find what is the dimensional formula. Adepade same equation. What is the equation? The force magnitude between the two charges is equal to what? K into product of magnitudes of the charges, mod q1 into mod q divided by r square dana. So idhula enna varudhu parunga. So force means, force or dimensional formula enna? ml t power minus 2 is equal to k. Adha namakku theriyadu, adha nama find out pananum. Q, charge dimensional formula enna theriyuma? Charge will be equal to what? Current into time. So A into T. Here A is the dimensional symbol for current and T is the dimensional symbol for what? Time. Other than one more charge means one more A into T divided by R square. R represents what? Length than a distance. So L square varum. So we have to take everything to the left hand side eduthu ponom. So this will go to the numerator and the madri it will come to the numerator. Paranga, what is it? K over dimensional formula will be equal to what? M L cube T power minus 2 divided by A square T square. ஓகேவா? ஸோ ஃபைனலி நம்ம சிம்பிளிஃபை பண்ண என்ன வரும் பாருங்க, m l cube t power -4 வரும், a power -2. இதுதான் dimensional symbol for or dimensional formula for the Coulomb's constant K. So check பண்ணுங்க, what is it students? What is it? m l cube t power -4 into a power -2. Okay, current oda symbol either we can use a anu vechikalam, illana we can also use the symbol I. Either we will use the symbol a, illana we can use the symbol I. Okay va? So this is about the understanding of the Coulomb's constant. What is the SI unit of the Coulomb's constant and the madri, what is the dimensional formula for the Coulomb's constant. Okay, இன்னொன்னு தெரியுமா, when we discuss about the Newton's law of gravitation, அதுல பாருங்க Newton's law of gravitation என்ன நம்ம சொல்லுவோம், the force of attraction between two masses is given by what, g into m1 m2 by r square. நீங்க பார்க்கலாம் அதுக்கு இதுக்கு இருக்க similarities. Here what is it, the force of attraction or repulsion between charges will be equal to what, k into mod q1 into mod q2 by r square. ரெண்டு expressions நீங்க பார்த்தா what you are going to see, you will see a similarity. Both follow the inverse square law. In terms of distance, ரெண்டுத்துல என்ன இருக்கா, the dependency is what, like 1 by r square type, inverse square law in terms of distance relation. Okay, and here if you see the constant, right, you know what we call it as, என்ன சொல்லுவோம், we'll call it as what, universal gravitational constant. Another universal gravitational constant. Okay va? So what is called as universal? Universal another, whenever some constants are always going to constant independent of the other parameters. Ena if you are having the two masses in vacuum or air, or you take the two masses to water, so on the same masses you keep them in water, and the madri take them into some oil or some other medium, நம்ம எங்க போனாலுமே the value of g is going to be always remaining constant. So that is the reason why we call it as what, universal constant and சொல்லுவோம். Okay va? அந்த மாதிரி remember we also call the gas constant capital R as what, universal gas constant. So அதுக்கு என்ன சொல்லுவோம், we'll call it as what, universal gas constant. எதுக்கு, because the gas constant, whether we are referring to the oxygen gas or hydrogen gas or nitrogen gas, any gas you are referring to, and the constant value will be what, always not going to change. அதுக்கு தான் நம்ம என்ன சொல்லுவோம், universal gas constant சொல்லுவோம். But இங்க நம்ம அப்படி சொல்லல, we said வெறும் Coulomb's constant, we didn't say universal Coulomb's constant. Did we say that? We are just saying Coulomb's constant. So which means what, this Coulomb's constant will not be always a constant, means it is going to depend upon something. It is going to depend upon actually the medium. On what it is going to depend upon, it is going to be depending upon the medium where the charges are kept. Okay, so remember the Coulomb's constant is going to depend upon the medium where the charges are kept. So it is going to depend upon the medium where the charges are kept. Okay va? And here we are going to talk about one property of the medium which is related to the electrical behavior. Okay, so we will call that property as permittivity and solve. What is the property called as permittivity? Idu patti we are going to learn in little bit more detail as we go into the chapter. Okay, so sometime later we will study in detail about the permittivity. But ippodhukku enna theriyuma, we need to understand that permittivity will generally represent by the symbol epsilon. Eppadi nama eludradhu, oru e curved e madri. Okay va? So this is what is symbol we use, and eppadi adu pronounce pandrathu epsilon. Okay, so epsilon is what, permittivity. It is a property of the medium. Okay, so what kind of property, we'll study about it little bit detail later. But ippodhukku enna theriyuma, just think about it. This permittivity property, it represents ability of a medium to allow electric field to propagate. So the medium kulla, how it is allowing the electric field to propagate. So normally நம்ம அந்த speed of light context la என்ன சொல்லுவோம், refractive index னு சொல்லுவோம். So what is refractive index? What is refractive index n? What is refractive index n? It is what? It is the optical property of the medium. refractive index சொன்னா what is it? Optical property தானா. So what is it representing? It represents the ability of the medium to allow the light to propagate through that. அதுதானா. So what is the refractive index or significance? It tells ability of the medium to allow the light to propagate through it. அந்த மாதிரி இங்க என்னது? இதுக்கு என்ன சொல்லுவோம்? Permittivity ன்னு சொல்லுவோம். Okay. So permittivity is what? It is the ability of the medium to allow electric field to propagate through it. இது பத்தி we are going to learn about it in detail. Okay. But here we need to understand that this K value, right, in the Coulomb's constant is going to be depending upon, it is going to be depending upon this electrical property of the medium. What is it? Permittivity. How it is going to be depending upon this? The value of K will be equal to 1 by 4 pi epsilon. Another, what is the relation? The value of K will be equal to what? 1 by 4 pi epsilon. That is the exact relation. Okay. So from medium to medium, and the epsilon value change agum. Epsilon is what? The permittivity of the medium, right? It depends upon, like normally refractive index and sonna, refractive index is going to change from medium to medium dana. And the permittivity value also will be changing from medium to medium. Okay. So one of the most common medium that we all use, the medium of air or the medium of vacuum. For the medium of air or vacuum, the permittivity is generally represented by this notation epsilon naught, and the epsilon subscript or naught. Okay, va? O madri. Okay. So this epsilon naught represents what? It represents the permittivity of the vacuum or free space or air. The value will be almost same. Okay. And here it will be interesting to see one thing. Epsilon unit, right, will be what? Reciprocal to the K unit. Paranga. What will be the epsilon unit? Epsilon unit will be what? Reciprocal to the K unit. And what is the relation? K is equal to what? 1 by 4 pi epsilon. Okay. So the unit of epsilon will be what? Reciprocal to the unit of the Coulomb's constant K. Okay. So the value of permittivity of that vacuum or free space or air is 8.85 into 10 power minus 12 Coulomb square divided by Newton meter square. Paranga unit, it is what? Reciprocal, and the SI unit value is what? Reciprocal to the SI unit of the Coulomb's constant. Okay, wow. So this is the epsilon naught. In the value corresponding, so if you put 1 by 4 pi epsilon naught, substitute panna idhula enna varum? We are going to get the Coulomb's constant K for the medium of air or vacuum or free space. Adana. So whichever medium we take the permittivity value on the expression substitute panna, we are going to get the corresponding medium or Coulomb's constant K. In the 8.85 into 10 power minus 12, 83 substitute panna, we are going to get the value of K to be approximately 9 into 10 power 9 Newton meter square per Coulomb square. This is the K value. What is this? This is the value of K for the vacuum or air or free space. This is the value of K for the vacuum or air or free space. Okay, va? And this value, K value, it will be changing from medium to medium. The value of K will be changing from medium to medium. Okay, va? So this is about how the Coulomb's constant will depend upon the medium. Remember, in the very beginning of the discussion we said people found that the electrostatic force, the force electrostatic force and like most of the experiments that are done, including the Coulomb's experiments, right, they were trying to do the experiments by holding the charges at rest, static charges. Most of the experiments on the charges were done by using what? Static charges. So other than the electrostatic force vardu. Okay, so that's where we are getting the word electrostatic. Okay, now the force that we are discussing, right, can exist between moving charges also. So it's not like always the charges have to be at rest. Q1 and Q2 have to be at rest. It's not like always they have to be at rest. Even though they are in motion, they will still exert this force. So by that logic, right, the electrostatic force and so on, it's a misnomer. Electrostatic means, what do people think? They'll think that, okay, only when the charges are at rest, they will exert the force. Even when the charges, like say, they both are moving, still they will exert force. they are repelling means they will still keep repelling. Okay va? Now when we talked about the comparison between the gravitational force and the electrostatic force, we said the electrostatic force is a stronger force, gravitational force is a weaker force. எப்படி தெரியுமா இது கம்பேர் பண்றது? Just think about the values of the constant and the force expression la in the Newton's law of gravitation. Idhula what is the constant here? Capital G dana. What is the capital G oda value? Universal gravitational constant 6.67 in 10 power minus 11 Newton meter square per kg square. Idana, this is the value of capital G. Compare panni parunga, that is what 6.67 10 power minus 11. Idanadi for at least நம்ம எதுக்காக நம்ம எடுக்கிறோம் இந்த k value, vacuum or free space or air. என்னது, what is the value? 9 into 10 power 9 பாருங்க. So for the capital G, what is the exponential term? 10 power minus 11. இதுல என்ன 10 power 9. So you see, when you compare the constants between the two forces, right, you can check why there is a large difference in terms of the strength of these forces, because it is decided by what? The constants. Okay va? Now we'll do little bit more study on this permittivity before we go into the next discussion. Okay, so இதுக்கு முன்னாடி நம்ம என்ன எழுதிருக்கோம்? அந்த ஃபார்முலா, கூலும்ஸ் லா ஃபார்முலா, the strength of the force magnitude is equal to what? K into modulus of q1 into modulus of q2 by r square. இதுதானா? So இப்போ என்ன தெரியுமா, in place of K we can also write it like this, 1 by 4 pi epsilon. Okay va? So in place of K, what we can write? 1 by 4 pi epsilon. And we said the permittivity of the medium will change. So if the medium is air means it will have value. We know that value. What is it? For the vacuum or air or free space, what is the permittivity value? We are representing by the symbol epsilon naught. That value is 8.85 into 10 power minus 12 Coulomb square Newton meter square. This is what is the epsilon naught value. Okay, now when we look at the medium, any other medium, whether it is the water or oil, whatever it is, any other medium, right, this epsilon value for those mediums is going to look as complicated as epsilon naught, because it is not very easy to remember the values, right? Paranga, what is the value of epsilon naught? 8.85 10 power minus 12. It's not very easy to remember. If it is only one value or no, we can remember. But on the madre, if somebody is giving water or epsilon value, or somebody is giving the oil epsilon value, somebody is giving the mica epsilon value, இதெல்லாம் நம்ம remember பண்ண முடியுமா? பண்ண முடியாது. So what is introduced is easy method or easy approach to remember. இது எப்படி தெரியுமா? Generally we use the concept of relative density. Remember, relative density என்னது? If you have density of any medium, we divide that by density of the reference. Generally நம்ம எடுக்கிறது, in case of density we will take water as the reference. பாருங்க, if you take the density of mercury as 13,600 kg per meter cube, density of water is what? Approximately 1000 kg per meter cube. Okay va? So ratio edutha what you are going to get? Simply we are going to get the number 13.6. So when you take the relative density concept, right, we divide the density of any given medium with the density of the reference substance. Then we generally will take it as water. We are going to get some simple numbers, easy to remember. Same approach, right? Here also we use the concept of relative permittivity. Another same approach. So relative permittivity, like the way we talk about the relative density. So what is relative permittivity? This is represented by the symbol epsilon subscript r. So what is it? Any medium, adoda permittivity value epsilon divided by epsilon naught. We are dividing by what? Reference. We are taking the reference as what? The air or vacuum or free space. That's our reference. Okay va? So the permittivity of any medium divided by permittivity of the vacuum, that is what we are calling as the relative permittivity. We are calling it as relative permittivity. These relative permittivity values are going to come like very simple numbers. The relative permittivity values are going to come like very simple numbers. Okay, Like if you talk about say mica, the value of this will be close to 6. If you talk about water, the value of this will be close to 80. Like that we'll get some really easy numbers to remember. Okay va? So this is the concept of the relative permittivity. Idukapra enna theriyuma, we don't need to remember the actual permittivity value of each and every medium. Adu namakku thevilla. If you are able to remember these simple numbers, we can find out what is the permittivity of the respective medium. Eppadi theriyuma inga parunga, அப்படியே நம்ம அந்த equation just remember it now. So we'll just bring this epsilon naught to the left hand side. Numerator lo poidum. So what is it? Epsilon naught into epsilon r is equal to what? Epsilon. So for any medium, if you know the relative permittivity of the value, like we say for mica it is 6, means for the mica what is the permittivity value going to be? It will be what? Epsilon naught, which is 8.85 in 10 power minus 12 coulomb square into 6. All that. Because anyway we are going to remember this value epsilon naught eppadiyaadu we are going to remember. Adukku nam enna pannom verum and the multiplication epsilon naught value just we have to multiply. And the madre water and sonna, what is it going to be? We have to multiply to the epsilon naught value, we have to multiply the number 80. All that. We are going to get what is the permittivity of the vacuum. Okay, so this is the concept of the permittivity and relative permittivity. Okay, ingon enna theriyuma, what will be the unit of the permittivity we have seen? SI unit, just reciprocal of the Coulomb's constant. And the madri, if somebody is asking what is the dimensional formula for the permittivity, what is it going to be? Appadiye reverse dana. So whatever the dimensional formula for you have for K, adukku appadiye reverse varum. Okay, so dimensional formula for permittivity is what? Just reciprocal. Okay, engenga and the power plus irukku adella minus aidum, engenga power is minus, that all will become what? Plus. Okay, so that is how we are going to look at the relation between the Coulomb's constant and then permittivity. Okay, so just before we conclude the session, right, we'll try to solve some very basic questions. There are two charges, two small m and sonna theriyuma, milli. What is small m? Milli. Milli means what? 2 in 10 power minus 3. Milli subscript is what? 10 power minus 3 dana. And 4 mu means what? Micro. Micron another 10 power minus 6. So two charges are there, 2 millicoulombs, adukapram 4 microcoulombs are at a separation of 2 centimeters in the air. Okay, 2 centimeters sonna, what is the corresponding SI unit value? What is it? 2 into minus 2, 10 power minus 2 meter. What is 1 centimeter? 10 power minus 2 meters dana. What is the nature of force between them and its magnitude? Enna kekranga, they are asking what is the nature of force between them. So nature nam appadiye sollala. What is it? Paranga, we have a 2 millicoulomb, but adana the positive charge. Adukapra we have 4 microcoulomb, adu positive charge dana. So 2 positive charges, what they are going to do? They are going to after all repel. So first part appadiye vandhathu. What is it? These two force charges are going to what? Repel. So the nature of force is what? Repulsive. Another, what is the nature of the force? Repulsive. Adukapra they are asking what is the magnitude of the force? Straight formula dana, and the Coulomb's law formula, what is it? K into modulus of Q1 into modulus of Q2 by R square. Okay, paranga K evada, everything we are taking the SI unit. K another SI unit 9 10 power 9. Adukapram each charge is positive only. So modulus of positive number is positive only. Modulus of negative number is also positive. Okay va? So inga paranga first charge enna 2 into 10 power minus 3. And the madri second charge 4 into 10 power minus 6 divided by denominator R square. Everything is in the SI system. So idilande vara force value, right, will be in which unit? Newtons dana. So inga paranga 10 power 9 and the madri 10 power minus 6, 10 power minus 3. What is 10 power minus 6 in 10 power minus 3, 10 power minus 9? Adella cancel adu. Okay, so remember where enna iruka? 9 into 2 into 4. Denominator la square pananum. 2 square another 4. 10 power minus 2 square means 10 power minus 4. Idhil in the 4 and the 4 cancel adum. What is it? 18 into 10 power 4 newtons. What is it? 18 into 10 power 4 newtons. Check it, students. What must be the answer? 18 into 10 power 4 newtons. Okay. So we have got the basic idea of what is this Coulomb's law. Every and the very straightforward question. This is a very straightforward question on the Coulomb's law. Just verum on the formula we are just taking the values and substituting. Okay. So next class we'll start with some more applications of the Coulomb's law. Every and the Coulomb's law, how we are going to apply in terms of the actual questions. Neatly, right? We are going to get most of the times questions, especially in the electrostatics. If one question is coming from this in the Coulomb's law part, another question is going to come from the capacitors. So most of the times, we'll have questions appearing from the Coulomb's law expression based panni, at least the applications of the Coulomb's law. Okay, so we'll have to focus a little bit more on this, and we'll continue in the next session. Okay.